Hello students, I hope you all are fine at your home. So now we're starting a topic which is from the physics part of your science book and which is the chapter number 8. The name is motion. We are starting this chapter now. So there are some terms that motion, resting phase. I hope you all know these terms, but I'm revising it again. So motion, what do you mean by the term motion? So motion is said to be a phenomenon when a body, object, or a particle is changes its position continuously with time. That means whenever a object run from its position and just reach another position at specific interval of time and continuously changing its position with respect to time, that means a object is covering a specific distance. So that is about the motion. And the second one is resting phase is just opposite of the motion. That means that whenever an object does not change its position with time, that means it stays in its position and does not changing with its speed or its time, its position with time, so the object is said to be in the resting phase. Now these are the two terms which is the common terms we have to know before starting the chapter. So moving to the chapter, your first main topic about this chapter is the motion along a straight line. So what do you mean by the motion? You all get it. Now motion along the straight line, that means an object is starting on motion and it goes into a straight line. So that is the motion along the straight line. Here two terms I am defining here. First is distance and second one is displacement. What is distance? Distance is the total path covered by the object. That is whatever the speed, whatever the way, but the total distance which is being covered by the object or the particle is said to be the distance covered by the object or the particle. And what is the displacement? Displacement is the shortest distance measured by the object in the initial position and the final position. So I'm taking a common example to make you understand this, that at the morning you all go at the school from your home. Suppose your distance from the home to the school is 2 kilometers, and whenever you just go from home to the school you cover a distance of 2 kilometers, and when you came back to the home you also cover the same distance, that is 2 kilometers. So what amount of distance you all covered in the proper way? It is 4 kilometers. Get it? But what is displacement? Displacement is what is your initial position. Your initial position from where you start taking the distance is your home, and the final wave after this close of the school you came back to the home, and the final position is also what? Final position is also home. So the displacement will be 0. That means the displacement only differs or only depends upon the initial and the final position. No matter whenever the initial and the final position are same, the displacement will be 0. Now this is the common example I have taken. Now taking in one more example, here you can see a scale I have made, and here an object covers a distance. It start taking its distance from O and reaches to A, and in just coming to O, from starting position to the final position, it covers a distance of what? 60 kilometers. And when it goes back to the sea, it again covers a distance of 35 kilometers. So whenever I ask that what is the distance they completed in its journey, so the distance will be OC, because it just covers OC, then it goes to C to B, then B to A. In the whole journey it covers a distance of 60 kilometers, so the OA will be 60, and it back to the C that covers to 25, and the whole distance will be 35 kilometers, so the AC will be 35, and when we add the distance we get 95 kilometers. So the distance covered by an object here is 95 kilometers. But what if I asked what the displacement in this position? So all you know that in the whole journey, the journey will start at the position of O and at the position of C. You will get it. We start moving from O and we go to A, but A is the middle portion, and we just run from this position, and at last we came to C. So that is why our initial position is O and the final position is C. So here initial position is O and final position is C. Thus displacement will be, what is the initial position? It is 0, and what is the final position? It is 25. So here when we just calculate this, displacement formula is final minus initial position. So the final position here is 25 and the initial will be 0. So final minus initial is 25 kilometers. So this is the displacement in this criteria or in this situation. I am taking second condition here. In this second condition, what if the object started motion from O and came back to O? Just remind yourself, I'm just explaining this, that when you go from your home to school and came back to home again after completing the school, you will cover a distance of 4 kilometers, but the displacement will be 0. Here the condition will be same. The distance will be OA 60 and came back to O, that is 60, that is 120 kilometers, but displacement will be 0. Why it is 0? Because the initial and the final positions are same, so the displacement will be 0. So in this criteria, one thing is just clear in our mind, then what, when the distance, the difference between the distance and displacement is, the distance is the total path covered by the object, but displacement is the difference between the final and the initial position. And when the final and the initial position are same, then our displacement will be 0. So here the one more thing we have to keep in mind is SI unit of both the distance and displacement are meter. So the SI unit of both the displacement and distance will be meter, and the further topics are velocity, speed and time graph and etc. will be discussed in the later lecture. And I hope the way we have learned these things you have kept in mind and you understand. So revise this by yourself and we will discuss the further topics in the next chapter or in the next lecture. Okay, so thank you students, have a nice day.